Okay. Hii Kenya, stima imekuwa na tabia ya kupotea. Every few months, there's a national blackout, and this has been the topic of memes and conspiracy theories. So, today let's talk about the power grid. The power grid is made up of three main components. There's generation, transmission, and distribution. In Kenya, there's a government agency responsible for each of these components. So, I want us to look at what these components entail and who is responsible for them here in Kenya. Nani kununulia stima ikipotea kimzima juu mi sidhani ni Kenya Power. So just hear me out. Now, the first component of the power grid is generation. This is mostly done using turbines and generators. Turbines convert kinetic energy of fast-moving fluids into rotational energy that is used by generators to produce electricity. In Kenya, the primary source of energy is geothermal sources, hydroelectric dams, wind, solar, and fossil fuels. Stima yenye tunatumia inategemea hizi, naweza sema hizi ndio nguvu za umeme. Anyway, the organization responsible for power generation in Kenya is mostly KenGen, but there are other independent power producers which work together with KenGen. Component number 2 of the power grid is transmission. Transmission is made up of step-up transformers and long-distance high-voltage lines. Step-up transformers located at power plants receive electricity from generators and boost it to very high voltages that can be transmitted through long-distance transmission lines. These lines deliver power to substations. Hizi laini hupitisha nguvu nyingi za umeme hadi ikipita karibu nayo unaweza sikia sauti ya stima ikipita. In Kenya, KETRACO is responsible for transmission lines and substations. The third component is distribution. Much like transmission, distribution is also done using transformers and power lines, except the transformers used for distribution are step-down transformers which lower the voltages to levels that are suitable for consumer appliances. Distribution begins from substations which receive power from long-distance transmission lines. From the substations, distribution is done using low-voltage power lines which deliver power to every street. Kenya Power is responsible for putting up and maintaining distribution lines, as well as primary and secondary substations. Hizi laini na transformers ndio watu huona sana sana, na ndio maana pia tunapenda kulaumu Kenya Power stima ikipotea. Lakini ukweli ni kwamba lawama haiwezi kuwa ya upekee. In fact, when we experience national blackouts, Kenya Power is hardly to blame. Here's why. Like I said, Kenya Power is responsible for maintaining distribution lines and substations. In fact, they manage hundreds of substations across the country. For the distribution system to cause a national blackout, several substations will have to fail or shut down. This is highly unlikely to occur. So, how exactly does a national blackout occur? Now, typically, the grid operates at a frequency between 50 and 60 Hz. Hii inakuwa imeandikwa kwa kitu yote inatumia stima. So, the thing is, if demand for electricity exceeds the supply, there's an overload on the grid and the operating frequency drops below the typical range. This triggers a shutdown of power plants, causing widespread blackout. Similarly, if there's excess supply of electricity into the grid, the frequencies will raise above the normal range and trigger a shutdown as well. Now, it's more likely for the grid to fail because of excess demand, which causes overload. But excess supply of electricity is less of a problem. In fact, supply of electricity has to be slightly higher for the grid to stay functional. This is one of the reasons why the electricity we consume is usually less than what's actually generated. And this brings us to a problem known as grid balancing. Much like any other product, demand and supply of electricity is constantly fluctuating between peak and off-peak times. However, the grid has no means to store electricity to accommodate for these fluctuations. The electricity you're using right now has only been generated a few seconds ago. So, in order to balance between supply and demand, we must interconnect generators from various primary energy sources such that they can accommodate fluctuations in demand and supply to keep the grid stable at all times. Ni kama venye huku Kenya, electricity ikipungua, tunatumia thermal engines compensate. Hii iko na uzuri yake na pia ubaya. The grid is able to stay functional because of the interconnection that balances between demand and supply. But this interconnection also makes the grid vulnerable to what's known as cascading failures, which is just a fancy name for a widespread blackout. Again, what happens is that in the event of a significant overload on the grid, a shutdown is triggered at one plant. This further overloads other power plants, triggering a cascade of shutdowns until the whole grid goes down. Even the stima hupotea Kenya mzima. There are ways to prevent a cascading failure. They usually involve cutting power to designated areas. This is something distributors like Kenya Power will do when they expect supply to drop. They like to call it power rationing. But if supply drops unexpectedly, a cascading failure will occur, and there's nothing they can do about it. That's because cascading failures affect generators, and Kenya Power isn't responsible for that. In fact, the last national blackout in Kenya occurred because of the failure of a generator at Lake Turkana wind power station. Another cause of national blackouts is faults in the transmission lines or transmission substations. If a fault occurs on a major transmission line, there's a massive drop in power supply that overloads the remaining part of the grid and triggers a similar cascading shutdown. Recovering from these shutdowns is not easy. It's not like they just flip a switch and everything is back on. It takes a calculated and coordinated effort by all sector partners to reboot the whole grid without triggering another shutdown. Kwa wanasema hivyo kwa official statement, lakini Wakenya nalalamika lazima. Also, the reason for these shutdowns is to protect electrical equipment from damage, which will take far longer than a few hours to repair. Anyway, in the future, grid balancing will be made easier when we can store power at a massive scale. This can be done using megawatt battery packs and other methods like pump storage, which are already being used in some countries. Batteries in EVs could also help with power storage by charging during off-peak hours to store electricity when the demand is low. This is another reason why adoption of electric vehicles is important. So, as I finish, the national grid is practically the heartbeat that powers everything we do. Everyone's lives is directly affected when there's no electricity. Mood huwa inabadilika juu ya stima kupotea. So, let's not be oblivious of how this model of engineering works. Instead of being quick to complain, let's indulge ourselves in a little bit of curiosity. We might learn a thing or two. Always, the future is electric. Feel free to leave a like and comment below. Also, don't forget to subscribe. Thanks for watching. Next time.